like what the toString method is for hash table, you'd probably be okay. But yeah, I would. You can comment it out or put it in a different method just to sort of preserve it for posterity. But I would go ahead and just make your actual toString just a return of your hash table dot toString.
Okay, awesome.
Mm-hmm.
Yeah, it looks exactly the same. It's just I didn't realize there was that .toString. So
Yeah, probably a bit of work you did then.
a little bit.
Mm-hmm.
It wasn't too bad. But yeah, like I used iteration, so
Excellent.
it helped a lot.
All right, I think we are here. Cool. I think we're up and going. If nagging feeling I'm forgetting something, but this happens. All right. Other questions?
Yeah, I had a quick question about the method locationOf.
Mm-hmm.
For the locationOf, could we do that, or did you want us to use like less than 0 or greater than 0? Did you want us to do it that way, or can we use a try catch?
Don't use a try catch. In general, I don't want you to use try catch unless there's no other option. For example, if someone asks you to open a file, you don't really have a lot of convenient choice for knowing if that's going to succeed or not. That's a good place for a try catch. But to see if an array index is going out of bounds, just use an if statement.
All right, thank you.
Mm-hmm.
Yeah, I'm kind of curious about that too, because some of my methods, they basically check like 3 things. So I have like this or this.
Mm-hmm.
And okay, that's pretty normal then.
Yeah, definitely.
Okay. Oh, the other thing too, I know it said in the assignment if processing file fails. Is there a way to check if that's false, like in another method, or because we're not processing it there, we can't really set it to a bool?
So when you call processFile, you're going to try to open the file and construct a scanner with it. That's going to be in a try catch block. So if it fails, set a flag somewhere in your class saying we have not processed a file, and then just return from processFile a false. But keep a flag in your class that you yourself will refer to that basically tells you, have you successfully processed a file? And every one of these other methods says blah, blah, blah. If you have not successfully processed a file, then blah, right? So most of these methods want to know that information. Have you successfully run processFile? So just keep a Boolean in the class. You can make it private, and this can be used. So if you call a number of instances, you can say, oh, haven't processed a file yet. I'll just return -1.
Okay, so the way that I did it, I basically did a check on index,
Mm-hmm.
the hash table, and if it was set to null, that means I have not processed a file yet.
That's good, but what if somebody calls processFile a second time and that second time it fails?
Okay.
You would want to make sure you reset that hash table index to null to indicate that you failed to process.
So, could I have a suggestion, a funny one?
Mm-hmm.
If you're going to go through cleanup word and make a new string and add all the capital characters to it,
Mm-hmm.
sending it with plus, it's going to be a big problem when Nick hits it with War and Peace, because you may need to call cleanup word multiple times, and every time you use that plus concatenation, it's another allocation of memory. So when you have to do a lot of words and every letter in a word, and maybe that word multiple times, it's going to be really noticeably slow. I think it was for me when I hit it with a huge file of text.
Makes sense in theory. I believe Java will do a reasonable job of freeing up that memory pretty quickly.
Really?
Yeah, because I've run this on large input files and not had any sort of noticeable. I mean, other than the time it takes to ingest that much data. But
Did you use a replace all, or did you like concatenate a bunch of?
Just concatenating.
Oh really?
Yeah, just one letter at a time.
I made a huge file of ASDF
Mm-hmm.
strings, and it was like 90,000 lines of text.
Cool.
And just broke it for about 5 minutes.
Interesting. Trying to think if there's something else I could imagine that might be going on. I don't know, but it should not slow down the JVM to concatenate things one character at a time. The memory management should be very easily handling that. As far as I know, and as far as my experience.
I've always been told it's bad practice, so I'm not exactly sure. You could be right.
Bad practice to concatenate a bunch of things together?
Well, like if you have the option of a string format versus concatenating with a plus sign a bunch of times, then the format's only going to do like one allocation. And it might be a problem when you have just a lot of text. It saves you lots of allocations of memory.
I'm willing to bet if you look at the code for that format, it's probably doing the same thing you would be doing by just concatenating a character at a time, but probably a lot of other stuff too.
Fair enough.
But it would be interesting. You can download the source code and see what it actually does. We'll pull down some source code later on this term and eyeball some of these classes like scanner and see what they actually do, because most of these classes are written in Java. Very few of them are written in anything lower level. So as we learn Java, we can understand how these things are implemented. And when you get an exception, you see the actual line number in scanner.java line 564 called such and such. We can go back and we can look at the source and actually use that to help figure out what's going on. So it'd be interesting to see what some of those other string processings are actually doing. All right, and yeah, I will try to break people's code a little, or at least stress it out with some large test files. But mostly I want to know that your code works and that it has the right methods and so on. So I'll run it on pretty small, simple test files. But I will probably try it on a really huge file just to kind of see what it does. So that's a good additional test. Awesome. Other questions or comments?
Sorry, I didn't realize I was unmuted.
That's okay.
I do have a quick question. So, basically, if you set that flat for the full, whether it's process or not, right?
Mm-hmm.
Should you still check if your hash table is set to null as well, or is that going to pretty much be kind of a double check of the same thing?
So I would think processFile. What do we want to do in there? Let's see. So rough approximate pseudocode for processFile. Try to open file. If it fails, success equals false. And return false. Otherwise, I'm going to set success equals true, index equals new, hash, etc., etc. Read, clean, add, and then return true. I think that's the basic setup. So go ahead.
Right there, on the last assignment, you gave me some critique on the try catch, and I was putting the open file, read file in the try, and then obviously the catch was the flags you have there. So should I just try to open the file, and if it doesn't open, then set the flags, or should I keep my code where it's reading through the file in the try block?
No, I wouldn't do anything in the try block except things that might throw an exception. And once we get success from scanner, as long as you're doing has next before you do next, there should not be any possibility of an exception. So I would.
I should basically have one line then.
I think it should have one line, which is, you know, input scanner equals new scanner, new file, file name. And the catch would simply be something that, you know, sets this flag to false and returns. So this is your catch. And then your try catch is done right here, and this is all outside, just in the regular first level of processFile.
Okay, I'm glad I asked that question.
Okay,
Thank
cool.
you.
Yeah. And so you know, reading is just doing, you know, input scanner dot next, right? And then to clean it, you just pass it to cleanup word, and it gives you back a word. And to add that, you just call add reference with the word and with a position that, you know, is 1 the first time, 2 the second time, and so on and so forth. That's the location argument to add reference.
Yeah, I think the biggest headache of mine was ignoring the spaces or the extra characters, because that was incrementing my position.
Ah, okay.
So I had to figure out, I was starting to get really irritated.
Yeah. Yeah, so one of my reasons for suggesting a cleanup word was to sort of move that to a separate area of your code. So you could do read, clean, add, increment location. If you start your location at 1, if you start your location at 0, which is what I think I said to do, increment the location before you add. But, you know, either way. With one extra detail, which is, you know, add if, maybe after you clean, you know, if equal to quote, quote, don't use double equal signs. But if your string is empty, then just, you know, go back up and read the next word. So if you have an empty string after you clean up your input, don't add it to your hash table, don't increment your location. Just ignore it, go back and read the next word. So do a continue or something.
I think the smiley face was what was really throwing my code off for some reason. That was reading as an empty space. And,
Yeah.
Yeah.
So that when you convert it with cleanup word will give you back an empty string. And so if you go ahead and add it, it adds an empty string, which is not a big deal, but it also increments the location count, and then all the subsequent locations are off by 1.
It's funny how simple this program is, but it actually has a lot of places that you can get tripped up.
Oh, definitely, yeah. That's kind of the nature of the beast of programming, though. It's often the details. It's that comma that you forget to put in, and your ship crashes into an asteroid, you know.
Yeah, I was kind of curious about that, actually. I mean, if you're writing a program that's, you know, several 100,000 lines of code or something like that, someone misses a semicolon, that could be pretty detrimental, yeah?
It's a big problem. You know, if you're lucky, we're talking about syntax errors and your code won't even compile. But there are lots of opportunities for semantic errors, for edge cases that are overlooked, for, as we started to talk about the other day, when you have multiprocessing, for cases of deadlock or resource contention and so on that just don't come up in your tests. And those are the things that people really, really worry about. Those are the things that cost time and money and such.
I could see a for loop being inclusive instead of exclusive or vice versa.
Oh, yeah. Yeah.
A headache.
Data validation is such a big part of programming, honestly.
Mm-hmm.
Especially, like, yeah, it's... I don't know, I just spend a lot of time on data validation. So.
Yeah. And there's you can take whole courses in software engineering and, you know, study systems and methodologies to try to mitigate these issues to some degree. Languages are developed to try to mitigate these issues to some degree. So Java, you know, less chance of a null pointer exception, but they can still happen. Less chance of a buffer overrun when you read in input, but there's other things that can happen. And yeah, it's tricky. I mean, computers do crash. You know, sometimes your phone reboots itself for no reason. Well, that's a software error that came up. And if you consider how many billions of things are happening in parallel every second, it's remarkably rare. How many people here remember the Intel Pentium divide bug?
Is that on the Pentium 4?
I think it was the Pentium. I don't remember. It was an early instance of the Pentium. And there was a bug in the floating point software in the chip, right? A hardware issue where certain cases of doing floating point division would produce a tiny little error way out in one of the extreme decimal points. And a mathematician, I believe, found this and went through the code and you know, there's a bug here. And Intel's response was they did their own analysis and they said, yeah, this isn't going to be an issue for most people. No refunds, just live with it. And that was a great marketing lesson that's probably still being taught because, man, they got in trouble for that. and they tried to say if you can prove that you're using, you know, your PC to do mathematical calculations where this will potentially be an issue, then we'll send you a replacement chip. Not a good approach. So eventually they gave free replacements, and you can find tons of really good Intel Pentium jokes on the web now. So that's good.
I bet their legal department had a field day on that one.
Oh, I'm sure, yeah.
I saw some headline where they had some similar lawsuit they lost the other day, Intel,
Yeah?
on like some feature their chips didn't have. I don't remember all the specifics, but it's really funny when those hardware level bugs happen and it's just like way too expensive.
Yeah.
to fix, like
Yeah.
Spectre meltdown.
Right. Yeah, that was an intense one. That was so deep down and so fundamental to how a lot of the processor worked. That was
And everybody got hit with it, and everybody saw the performance tip.
Yep.
I remember it.
Yeah, that was interesting. And Bash, somebody found a bug a few years ago that was pretty serious, and had been there from, like, you know, the beginning of time, and nobody had noticed it for all that time. And you know, bugs are gonna happen. It's kind of inevitable.
Is a fork bomb considered a bug?
A
Or is
fork?
that-
No, that's a feature.
Oh, is it?
Yeah.
Okay. Interesting.
Not necessarily, but you know, if you have an accidental fork bomb in your code, yeah, that's a bug. But the fact that fork bombs are possible, that's just because that's what fork does. It's glorious, you know.
Interesting.
Yeah,
There are no bugs in nature.
right.
I love that word. It's a feature.
Yeah, that's the marketing angle. Yeah, if you're not familiar, fork bomb is basically where you just create a copy of your current process. And if you do that in a loop, then each of those processes will make a copy of themselves, and now you have 4 processes in each of them. And it's like a 2-line C program to do this. And if your system is set up well, there's a limit on how many processes a user is allowed to create. And the operating system will fail the job at some point, saying, no resources available for this. But on a bare bones system, it'll just crash the system.
Yeah, I think my brother and I used to email our friends these back in the day.
Yeah,
Like
yeah.
Those 97, 98.
Mm-hmm. Yeah, and email used to let you send non-printable characters in messages. And so some of the old terminals, they had escape sequences you could use to change the text to boldface or things like that. But you could also, on some of these machines, load in your own character set. And you could make it flip the display 180 degrees. You could send somebody an email, and when they see it, you know, suddenly their display is upside down or something, and it's good stuff.
So it like run the macro or something?
No, it was all just sending ASCII codes. It's like the talking cow, right? Or the steam locomotive when you say SL. Just ASCII art with control codes embedded. If you're really mean, you change their monitor to a refresh rate of 50 so it conflicts with the fluorescent lights, and you watch them get irritable for the rest of the afternoon. I would never do that, of course.
That's amazing.
All right. Other questions, comments. So I'm other than talking about PA2, and I'll do a quick run through on ODP 303 just to tie up any loose ends on that. But then I want to let's see. We've scanned from files. We've gone over hash maps. I want to look at linked lists again, and the linked list that we created, and I want to see how we can change that to work with different types of objects. And this is going to take us into the area of generics, which is something we've already used when we use a linked list or a hash map. We have to tell it what kinds of things are going into our data structure. So how do we implement that in our own classes? So we'll talk about creating generics, and we'll play with those. And then if we have time, I want to talk about print writers, which will round out a quartet of capabilities. So we currently know how to read and write from standard in into standard out. And we know how to read from a file using scanner. We still need to know how to write to a file, and we'll need that for PA3. So that's going to be a print writer. And print writers are super easy to use. They look just like system out print line, except it's printwriter.println. So not a whole lot to worry about there. So we'll talk about that, and then we'll start talking about trees some more. So let me just do a quick pass on ODP 303. So this was the famous A-class method, which builds an internal array of 10 integers and initializes them to 1, and then has a set and get pair of methods for putting a value into the array or reading a value out of a certain element in the array. And there's an example with no comments anywhere in sight. Instant 0 for the teacher. There's an example class. So the class is A class. It has an array called data, which is declared to be an integer array, but not yet constructed. I could make this private. That would work fine. And then the constructor, we go ahead and construct the integer array, and I just initialize it with a for loop. So just from 0 through 9, set each element equal to 1. And then here's the way we retrieve data. So we give it we set data, we give it an index and a value, and it just saves that value into that index element. And to get a value back, we give it an index, and it just returns that index. I have a keyword this in here. I'm still not ready to talk about this, so I'm going to get rid of that. Alright, there we go. So that should assess for 10 out of 10. Still compiles, didn't break anything. So any issues or complications with 303? Alright, I'll post an ODP 304 on Monday or on Sunday. It'll open up on, well, it'll be due on Wednesday. And I'll keep pushing out a few ODPs throughout the next few weeks.
a bit of feedback. I do appreciate the ODPs. I missed them last quarter.
Okay, cool. Yeah, I kind of missed them too. They're really good feedback for me. So, so thanks for letting me know.
Also, code golf is fun. It's fun to have a daily challenge like that.
Ah, yes.
Code golf? Is that a website?
No, it's like you can go look up silly programs that don't mean anything. Like I've seen one that's like C code that's shaped like a donut but produces a rotating ASCII donut, and it's just a bunch
Nice.
of silly challenges.
Oh, gotcha. Yeah, check it out.
Not that the ODPs are silly or anything, but it's
No, I get that. I just found N invaders, which is cool.
Is this on Linux natively?
No, but you can install it. Sudo apt install N invaders, and it's pretty good. Yeah. So there's some people in the world who aren't familiar with this, so got to correct that. And check out the graphics when you blow up. Come on, shoot me. Not shooting me. Oh, I gotta get the ship then. Oh. Come on, man, I'm right here. Get it. Alright, cool. No, it's got a little flash screen. Oh, it knows I quit. Alright. So let's talk about generics and linked lists. And so let me see what I got here. All right, so I believe we did a linked list of strings on in the previous class. And so here's the famous MyList class, right, that we've developed before, and it's going to implement a linked list of strings. So I keep track of a Sentinel node internally, which is just a node called Sentinel, right? And I keep that as kind of a global in my class. And this is super simplified. All I can do is add and convert to a string. So I'm not worrying about search or delete or anything like that. So to add a string to my linked list, what do? I create a new node, creatively called new node. I set the data value equal to n, the string that I'm trying to add. I set the next value equal to whatever Sentinel is pointing to, and then I tell Sentinel to point to my new node. So I'm creating a new node, putting it into the beginning of my linked list. And so each time I call add, it basically pushes it onto a stack. And then my toString method has a return string, which is empty to begin with. I start at the Sentinel, as long as start at what the Sentinel is pointing to, and as long as that's not null, append it to the return string, put a comma before it if appropriate, and move to the next node. And then at the end, I return the string that I built. So that's a simplified, two-method version of a linked list constructed by hand. And we can use this by saying, let's make a MyList called list. We construct it here, and then I just do a bunch of adds. And then at the end, I'll go ahead and concatenate it to a string and see what my list looks like. And it should be a comma-separated list. And the node class is super simple, right? It's just a data element called string and a next element, which is another node. So nothing intense going on there. And so if I compile this and I run it, bingo, we've got a linked list of strings in reverse order of how I added them. So I added goodbye at the end. That's the first thing that printed out in my string. Hello was the last, which was the first thing I added. So that's a linked list package. We've done this before. By itself, it's not terribly startling or inspiring. So here's what I want to do. I want to modify this. to work with integers instead of strings. So I'm gonna keep copies of these codes around so I can push them to the server for future reference. But you know, I obviously can't compile mylist-strings because it's still a class mylist. So I'm just keeping archives of these. So what's going to happen to main.java? I'm going to construct a new list, but instead of adding strings, I'm going to add integers. So I'll add a 10, and I'll add a 20, and I'll add a 30, and I'll add a negative big number, but not an imaginary one, and I'll add a big positive number. And then at the end, I'll print out what my linked list looks like. Right? Can't compile this successfully because I don't have a linked list class that expects integers. My add method is expecting strings. So here's the question: what do I have to change in this set of code to make this work with integers instead of strings? And it's non-rhetorical. I actually want answers.
Change the data type of your add method.
Okay, change the data type of our add method. Let's make this an integer. Let's just make it an int.
And also need to change inside of your node method. Right?
And in my node method, I need to change this to an int. And I think that's probably it. And there we go. There's our linked list of integers.
Curiously, could you have left it strings and just put double quotes? Wouldn't it print out the same values, or would it print the double quotes?
It would have, but I'd actually be storing strings. And then if I wanted to do something like, you know, sum these up or something, I would have to convert them to integers. So it would look like it was doing the right thing, but it would still just be strings. And maybe that would be something that I'd want to do.
Okay.
But if I actually want ints, I have to change it. And if I come in here and I change this add method to say this is an integer, and I change the data type to be an integer, this still works fine. So the relationship between primitives and classes is a little murky sometimes at first, but ints are kind of like, you know, a simplified version of the integer class. But if we actually need a class, it can be constructed on the fly from an int. And so calling my add method with an argument that's a digit like 2 or an int like n, and declaring that argument to take an integer uppercase I, that does not cause problems.
Is there some sort of constructor you can still use on the primitives? I've never understood that.
I don't think you can construct primitives. I think that's the essence of a primitive, is it's not an object.
That's what I was going to ask you, because, you know, in one of our, on PA2, we're using the character, you know, we're doing car, C, or S, whatever you chose, but then you're calling the character class to check if it's the letter, and that was weird to me until I kind of looked into it and I go, okay, I see what we're doing here. You know?
That's okay, because even though we're calling a static method from the character class, like isLetter or isDigit, the argument to that is primitive. It's a car ch.
So, is an array also still considered a primitive, like a primitive array of ints? Or
No, those
is
still
it
have to
not
be
a-
constructed.
Okay.
But don't ask me what kind of object that is, because I'm not sure what the answer is.
So you can, anything that's an object you can still use new on, but can't you like dynamically allocate primitives also? So is there some way you could use like new on a primitive for that?
I don't think you can make a new lowercase int.
Okay.
But let's just try it and see what the exact wording of the error is.
Right? I mean, because you're using int as a variable, it's not really an object.
There's no reason to, but I'm just curious.
So it doesn't even dignify our attempt.
It's interesting because I learned some stuff about C# last night that I didn't know you could do. Like, I knew there was an unsafe mode where you could play around with pointers.
Right.
Dynamically allocate stuff to
Yeah.
create yourself as if it was C.
Yeah, I just saw that myself.
Yeah.
Which is cool. Every language should have an unsafe mode, I think.
Right.
Right? So back when you used Fortran, you could just use like negative subscripts on arrays, and you could peek around the operating system that way, which is untold hours of fun.
Oh yeah.
All right. So this was not a big deal to change, from strings to integers. So suppose I want a linked list of rectangles. And you remember our rectangle class from the beginning of time, right? So same idea. I need to make two changes. Down here in my add method, I'm going to say let's add a rectangle. And in my node class, I'm going to say my data is a rectangle. And if you remember the rectangle class, it was a holder for a height and a width. We had a constructor that we could pass a height and width to, or just a length, and it would make a square for us. We had an area method, a perimeter method, a normalize, and a toString. So let's modify our main program to build a linked list of integers. So let's add a new rectangle. And I don't know, what should we add? Let's add a 2x3. Let's add a 4x5. I need two closing parentheses. Let's add a 1x1. Let's add a 10x12. And let's add a 100x200. And this should work, right? We changed our integer, formerly string, to rectangle in those two places. And if everything is working correctly in the universe, except this should be uppercase. And so we run this, and there's our linked list of rectangles. So our list is equal to a 200 by 100 rectangle, a 12 by 10 rectangle, a 1 by 1 rectangle, etc. And marvel at the fact that, we got human readable representations of our rectangles in our linked list for free, right? All we did in my MyList class was said, hey, let's take the data field of our node and append that to this return string that we're building. And in temp, which is a node, right? Temp.data is just declared to be a rectangle. But in our rectangle class, there's a toString method. And the toString method says, let's return this string a something by something rectangle. And that's the method that gets called when we do this appending of temp.data. And so kind of for free, you know, we get this human readable presentation of the contents of our list. And so this is all in the vein of, you know, thinking of classes as complete entities. Thinking of an object, an instance of a class, as having data and stuff that manipulates that data, right? ToString is a method that can be used to create a string that represents the data in an object. And we didn't have to say, you know, let's append, you know, a data.height by data.width rectangle to our output string, right? That capability is encapsulated inside the object, right? So encapsulation is one of the pillars of object-oriented programming, and it's taking all of these capabilities and kind of putting them inside the class or the object itself. And this works really strongly in favor of code reuse and of not having to reinvent the wheel. So as we move into later programming assignments where we're doing graphics and networking and things like that, right? We don't have to go down to the lowest level and say, you know, let's open a socketed connection to this thing, and let's take the bits coming in and figure out the IP address and so on, right? All that stuff will be bundled for us inside these classes that we'll use, like socket and URL and so on and so forth. And then we get to concentrate on, you know, the fun part, which is you know, let's grab a web page and let's, you know, display it, and if the person clicks on a link, let's do such and so on and so forth.
I've broke that class before as connection, just to have all the try catches for
Oh wow.
socket shuts down and whatnot.
That's a nightmare, isn't it?
Fun when you're right.
Yeah. There's so many error conditions there, and so many ways that you forget about that things can get shut down or shut down improperly, and that's always fun. Now, when you get to a university, you take a system programming course, you'll get to do all the stuff we're doing in here in C, and that's a whole different kind of experience. Because then you're working very low level and you're dealing with all of the possible details that can be going on, and I'm trying to talk to this machine, but it stores its 32-bit integers in reverse byte order, you know, and so I need to adjust for that because my machine is big endian and my destination is little endian, and all sorts of good details. So, but we'll have fun with all that stuff in here because we're in Java and it's nice and high level, and it's basically like, you know, it's like using Lego Mindstorm, right? It's like Legos but even better. If you've done 120 in
lower level stuff here, right?
yeah, I guess if you've done 120 in COVID, maybe you haven't played with Lego Mindstorms, which is really too bad. Because we used to use them in Engineering Computer Science 120, and people would build these little fighting robots and program them and then battle them against each other. It was like a 3-week lab.
I noticed in ancient 223 videos this class.
Yes. Yeah, awesome. All right. Well, so we've got the ability to pretty easily change our linked list class to work with different types of objects. And the trick to making this happen is really just changing two things. Where we see the word string in the add method and the node declaration, we have to change that to integer or rectangle or purple cow or whatever type of object we want to work with. So the idea of a generic is that we should not have to write different versions of our code just to work with different types of objects, if the code really is portable from one type to another. So let me save these. I wonder how many times I've tried to compile something.java. Ooh, once. Oh, haha. Twice. So let's make this generic. So, mylist.java. So here's the idea. I don't know if I want this to be rectangle or integer or string or purple cow. So I'm going to say when you construct a class mylist and when you declare something to be class mylist, I'm going to require you to specify a parameter, an argument basically. And so I'm going to put that argument inside angle brackets, and it can be anything I want. Usually it's a T or an E or some, single uppercase letter, but it could be anything I want. But I'm just going to call it T for type. And then all I'm going to do down here is instead of saying rectangle, I'm going to say T. And then what's going to happen inside main is when I construct my list, I'm going to say angle bracket rectangle. And when I declare a my list, I'm going to say my list angle bracket rectangle. So this looks like, when you use a linked list or a hash map, we're specifying these parameters. So this is a my list of type rectangle. It's a my list of type rectangle. And then my add method, I pass rectangles, obviously. So in the my list, the only thing I have to do is say, hey, the user is going to specify a parameter here, and I use that parameter right here. All right, so that's going to get us most of the way there. But we also have to make one more change. We have to change node.java. So if I try to compile right now, I'll get weird things. So let's because it thinks node is always going to be a rectangle, and I'm trying to save it as a type T. So let's fix our node class. And down here, instead of saying this is a rectangle, it's going to be a T. And I'm going to say when I construct a node, I have to specify a parameter. And now we're going to get some interesting error messages. What we're seeing is a warning. It says mylist.java uses unchecked or unsafe operations. Ooh. So this is like a warning. And you need to pay attention to these. You need to not just say, oh, it compiled, I'm okay, right? There's something going on that was probably unintended. And it gives a note here, recompile with -x lint, :unchecked for details. So lint is this stuff that you find on your clothes, and it doesn't really do any harm, but you'd kind of like to get rid of it if you've got time, right? You can go out in public and have, lint on the sleeve of your shirt and probably get away with it. But, it would be better if you didn't have it. And so, it would be nice to pick it off. So, the C compiler has a lint option. In fact, there's a whole lint program you can run in Linux that will look for things in your code that you can probably live with, but it would be better if they weren't there, right? And with Java, you can specify this -xlint option to see all the lint in your code. And you can say xlint : unchecked, but I'm just going to compile with just -xlint. And see what exactly is going on here. So nothing wrong with that. Six warnings with my list. And probably nothing much going on with Node. No, I've probably got issues in Node also. Nope. One warning in Node. So there's things that should be at least looked at and that probably you need to change. So what's happening here in my list? Line 2, it says warning, raw types found raw type node. Missing type argument for generic class node ;T, where T is a type variable. So it's telling me pretty explicitly what's going on if I can actually read between all of these lines. In line 2 of my list, I declared a sentinel, and I said this is an object of type node. Well, remember, node is generic, so I need to specify what type of object node is going to hold. So I'll go into mylist.java, go down to line 2, and what type of object should it hold? Well, whatever type I constructed mylist with. So that's again angle bracket T. So if we recompile, we're down to 4 warnings. Same thing here at line 7. Same thing at line, well, different error at line 8, and then the same thing at line 18. So let's pop back in here. Let's add an angle bracket T. Let's go down to line 18 and do the same thing. And here, you know, I'm declaring an object named temp, which is going to be a node of type T, but I'm not constructing it, right? This is like, you know, a temp we use in our linked list code when we're following from node to node. You don't need to do a malloc in C if you're planning to set temp equal to something. Well, here I'm setting temp equal to the sentinel node's next node, the thing sentinel points to. So I'm not doing a construction here, but I still need to declare it and say what type of node is this going to be. So we should be getting pretty close to clean. We've got 2 errors left. Sentinel.next should be a node angle bracket T, but in fact it's a node. And temp.next should be a node angle bracket T, but in fact it's a node. And so this is a problem in our node class. And a node has a data value, which is an object of type T. It also has a field called next, which points to a node, but it's not just a generic node, it's a node of type T. So I need that parameter in my declaration of the next field. And so now everything compiles, it's all super duper clean. And then if I run this, everything works great. And then if I wanted to change this to work with strings, all I do is change this to string, and then go ahead and, you know, add strings here, and this should work fine. So let's just go ahead and do that. So mylist angle bracket string, list2 equals new mylist angle bracket string.
Is there no like auto keyword or var keyword to use?
To do what?
So like instead of doing mylist generic string list2 new equals mylist generic string parentheses, like instead var list2 equals new mylist string parentheses.
And what would var be doing in that case?
It like auto determines the type, but only for locals. So
Oh.
it's like gaining popularity in C++, Python.
Yeah, I hope not. That's something Kotlin does too, and I guess if you're in that mindset and used to it, it's a convenient feature, but it can be pretty confusing if you're not in that mindset yet. And at least to me, I found it confusing in Kotlin. I don't think there's a version of that in Java. But I would say, you know, if you're working in Linux, you always have the option of making a custom preprocessor. And if there's particularly language elements that are unsavory to someone, you could, you know, change the Java command to run your input file through a preprocessor and then feed that to the compiler. And it would be pretty easy, I think, to add that kind of capability where you'd only have to specify the right side, and it would fill in the value on the left. And that would be kind of a fun project.
There's also like some sort of danger associated with that. I can't remember exactly what it was, but you're like encouraged to use auto and var and stuff like that today on one half of the declaration. You know. I can't
Interesting.
remember why though.
So weird things happen if you have a different type of variable. If you have a variable declared to be a different type from what it actually is, and sometimes that's perfectly appropriate. And this gets into a bit of like polymorphism and stuff where this thing is an extension of that thing, so it still is one of these things, but it's got some extra stuff. And so you can have sometimes an object of one type being assigned to an object of a different type. And that can get you into some interesting things too. All right, but I don't know if there's a built-in option for what you're describing in Java. So this was our original code. We did a mylist and we declared it to be a mylist of rectangles. Exactly the same mylist class here, but we're constructing it with a different parameter. So now list2 should be a list of strings, and we can still call, the add method of the mylist class, but this time it will be expecting string arguments instead of rectangles, and the string concatenation will be the same. Let me make sure this is list2. Didn't blow up. There you go. So there's a generic linked list class. And we don't need to do this for PA2, right? We probably don't need to do this for any of the programming assignments in this course. But if you're developing a package of classes on your own, for your own use, you may certainly find cases where, I want this to process this kind of object, that kind, or this other kind, and it's the same code in all cases, except maybe for, these small differences. Think about, maybe making it a generic. And that's what we see in HashMap, for example, right? The discussion we did where we were hashing things and storing them in arrays and searching and deleting and so on had very little to do with what the actual type of object was we were storing. The type of key, the type of value. The hash functions we used, we might have added ASCII codes or something, but we could make a hash function that's kind of independent of the nature of the key itself. We could just, add up bytes or 32-bit values and run it through some kind of mathematical function to hash it. Whether those bytes represent an integer, a double, a string, a pointer to a linked list, or whatever. So generics are useful and very much support code reuse. All right, so other questions, comments?
Doesn't come up too much in my experience. Like, for delegates it's super important, and collections is super important, but most times, like, that collection's already been written for you,
Right. All right, well, let's do a break. Let's come back in about 6 minutes. And we will we'll talk about iterators, which is a good hash map discussion. All right, so see you back in a few minutes. And I'm still getting a Coca-Cola.
I'll make you a coffee. Do you, whatever you like.
And a Coca-Cola.
Okay.
I'm also really thirsty.
Yeah. Generics are cool. I can think of like lots of ways to use them.
Oh, I'm sure. They were made for you.
started noticing this, like, whatever sticking out. That didn't used to be sticking out. I have to hang a calendar on it or something.
Yeah.
Little picture of us.
All right, we're almost back. Deciding what I want to do next. All right, let me talk about print writers next, actually, and then we can talk about iterators later. But print writers we're going to actually need for PA3. So you know that if you want to write to standard out, you can do system.out.println. So this is in the subject of I/O. And system is a class. Contains several useful class fields and methods and cannot be instantiated. System is kind of this general wrapper for some useful things, including the ability to read environment variables and run the garbage collector and exit and so on and so forth. It also includes some fields, and one of those fields is called out. And system.out is what's called a print stream. And print stream is a class that has a number of methods, including print and print line. And, you know, methods are identified by their signature, so a method's determined not just by the name, but by the type of argument it takes. And print line can take any of these types of arguments: a boolean, a character array, etc., etc., a string, which is what we often use, or it can take no arguments at all, which just prints out a new line. And there's a print method, which is like print line, but does not include the new line at the end. There's also a printf method, which lets us do output the same way we do it in C, with a string of format descriptors followed by the arguments, and so on and so forth. So when we say system.out.println, what we're actually doing is, uppercase system means this is a class named system, and out is a static field in there, and println is a static method for well, it's not a static method, it's a method for that out object. And so this prints to standard out. And then there's system.in, and so we can say scanner system.in. So if you look at the scanner class, one way to construct a scanner is with an input stream. And system comes with an input stream called in, which is an input stream. And so system.in is an input stream which is acceptable as an argument to the constructor of a scanner. So when we say new scanner system.in, this is our way of reading from standard in. And then the thing we talked about on Tuesday was we can construct a scanner with an argument that is a file, and the file itself can be constructed from a path name, and that will open up, access to that file and pull out its contents. And so we can create a scanner using a new file with some F name. And this opens up a file and ingests from there. So the last piece of this is how do we write to a file name. And the way that we're going to use for that is to use a print writer. And print writers look very much like what we do with system.out.println. But instead of writing to standard out, it's going to write to a file. So how do we construct a print writer? We can actually construct a print writer just with a string containing a file name. So we could also do it with a new file, but we can actually, for the output direction, just specify the name of the file as an argument to the print writer constructor.
Could you specify a stream like standard out, standard in, or not standard in, standard error, maybe?
We could specify an output stream. And I don't know if there's a system.error. Yeah, there is. So you could make a print writer on system.error, or I think you could just say system.error.println and get to the same descriptor. So we can say new print writer. So these are news. And we can just put the path directly in the constructor. And then once you have a print writer, you have all the methods you would like: print and print line with different types of arguments, print f with a format descriptor string, and so on and so forth. One additional detail: when you have a print writer and you're done using it, close it. Right? If you want to force output to get sent immediately to the file, go ahead and call flush. And so we've seen this in 224 in some cases, where we would write things into a file, and then if our program crashed, we might look and the file didn't actually have the stuff that we'd written into it because it was buffered. So this is a buffered output stream. If we want to flush the buffer out and force it into the file, we can call the flush method. This will be very pertinent when we're doing networking, because networking, a lot of times we don't want our output channel to be buffered. So let's play with this. So let's do a print writer main. And if you check the doc, it's probably java.io.printwriter. All right, so let's go ahead and do this. Print writer output equals new print writer. I know I spelled that wrong. And we'll write into our favorite file, haha.txt. Bless you. Alright, sample code, test file. So we'll open a print writer named haha.txt. There is no haha.txt in my directory right now, so this will be a newly created file if it works. So we'll open up a print writer to haha.txt. We'll say print line, a couple of things into it, and then we'll close the file. And this should create the file for us. So we will get a compile error saying you got to have a try-catch block here. And the problem is we might be trying to open a file that we don't have permission to open. So file not found exception. So in the print writer class, you can look at the constructor for a string. And file not found exception if given string does not denote an existing writable regular file, and a new regular file of that name cannot be created, or if some other error occurs. There's also a possible security exception. So we'll go ahead and capture this exception. And so, well, let me go ahead and do this the wrong way. Alright, so we put a try-catch block around our statement. This is still not going to compile because of this thing that happens sometimes when you try to add a try-catch statement. You have to change where you declare. Oh, there's another problem. I have to include that exception. So file not found exception comes from java.io. So we'll include that. All right. So we still get this error that it can't find the symbol output. And this is just this thing that happens sometimes when you add a try-catch statement around code that looks like it's correct. You have to think about the scoping of your variables. And in this case, I declared output to be a print writer, but I declared it inside this try block. It's local to that block. And so once I leave that try statement and I come down here, output does not exist. It's as if I had declared it in a totally different method or something. So the fix for that is very simple. Just declare it outside, but then give it the value inside the try-catch block, because declaring it is perfectly safe. That's never going to cause an exception. But it's when we try to construct the print writer that we potentially have an exception. So that's the statement that goes in the try block. But we're saving the result of that if it succeeds in this variable that's declared outside of the try block. So this output is available here and here as well as in here. And so that should compile fine, except for typos. Alright, so there's still no haha.txt in this directory. Let's run pmain, and now if I do an ls, there's a haha.txt, and it's got the stuff we just wrote into it.
Quick, unrelated question. We're not supposed to put empty strings in PA2?
Correct, yeah. If you pull in a token that does not have any letters, your cleanup word will turn it into an empty string. Don't add that to the index, just skip it.
Got it.
And that should actually be specified in here somewhere.
It says that it could be empty, not that it shouldn't be in there, but on the sample program, it doesn't show it, so I was just
right.
asking to make sure.
So I think when I describe the implementation, it says if the word is not empty, increment the position counter first and then call your add reference method.
Oh, I missed that one right there. Okay, I'm sorry.
There's 7 pages of stuff, so it's really easy to miss details. So yeah, always ask. All right, so this works fine. And if haha.txt already exists and it's got my killer autobiography inside, and then I go ahead and I run this program, it will just silently overwrite what was in that file, and that's not an error condition, right? The behavior of fopen in C, the behavior of constructing a print writer is if the file already exists, truncate it, right, and then begin writing into it. So you're not going to see any warnings or any second chances to change your mind, right? Now in Java, if you wanted to, warn the user that this file already exists, you can do that, right? So you can do things like in the file class, construct a file from that given path, and you can do things like does it exist? Test whether the file or directory already exists. And so on and so forth. Is it a file? Is it a directory? Is it hidden? And I think there's something in here to tell you if it's empty. I could be wrong about that. But anyway, so you can do these things on your own, but by the print writer method itself, if the file exists, is just going to truncate it and start from scratch. Now, if the file is not accessible, right, so I've changed the permission, so I have no permission to modify it. And now if I run this, I'll get an error message saying error opening haha.txt. So the try statement failed, it jumped down to the catch block, and I printed out my error message and exited. Same thing if I tried to open a file in a directory that does not exist. Right, I'll get an exception, and my catch block will save me in this case. Alright, so let's take a look at this business of closing. So I'm going to write my words into the file, and instead of closing it, I'm going to go into an infinite loop and just sit here and spin and drive up the fan speed on my laptop. And we're going to take a look at the output file from another window and see what it looks like. So let's compile this. It's being smart and telling me I can't actually get to this statement, so I'll comment that out. So here's our directory right now, and let me go ahead and run pmain. And now if I do an ls, I've got a haha.txt. If I do an ls-l, it tells me that file is 0 bytes long. And haha.txt does not have anything in it. But clearly I've already executed the statements that said print line, and I'm down here now, but the print line did not actually cause those lines to go into the file. They're in a holding buffer. And if I now terminate my program, those lines never end up in my file. And so if you're not ready to close your file, but you want to make sure that your output actually appears, that's when you can call output.flush. So this forces everything that you printed to go into the file. And so now if I run this and I look at haha, it's got that content in there. And now if I terminate my program, right, I've still got my output. So like I say, when we start doing networking, we're going to want to use flushes all the time, because usually we want to send a message to another machine. As soon as we say send this message, we want that message to actually go out. But the mechanism in most languages is, you say printf, or system.out.println, or echo, or whatever it is that you're doing, right? If you do these things into a file, they actually go into kind of like a pipeline, and this pipeline starts filling up. And the idea is, you might have 1,000 print statements, one right after another, and taking the contents of what you're printing and actually sending it to a hard drive, a disk, that's an expensive operation, right? This is old school mechanical device, right? A spinning platter of recording medium, spinning pretty slowly, right? 7,200 RPM if you're lucky. Takes a really long time. If every time that you tried to print a character into your file, you had to find the right location on the disk and write that character, your I/O would be really, really slow. So all of these print statements basically get saved up in memory. And if you've got a whole bunch of these, if you've got, say 4,000 of these or 16,000 of these, then the system will say, okay, let's go ahead and dump this whole buffer of characters onto the hard drive. And your hard drive, top view of a physical platter, it's got a bunch of sectors, it's spinning, you've got a read-write head sitting somewhere. If you're supposed to write into, this area of your drive, well, you have to move your head this far in, you have to wait for this thing to turn until this part of the disk is sitting underneath your read-write head. But once that happens, if you want to write 16,000 characters, that's pretty fast. As the disk is turning, you just keep pumping more characters onto the platter. That's an efficient operation. But trying to do this one character at a time, really, really slow. So most output is buffered. And that's a feature, right? Except when you don't want it, and then it's kind of like a bug. So Java has a lot of different versions of output with various levels of rawness or cookedness. And some output is intended for binary output or binary input. And some of it is meant for more kind of human readable stuff. And so print writers are kind of at the high end of the spectrum. They're usually used for stuff that's, readable by humans and pretty low bandwidth, and so all of these operations are buffered. So you can circumvent that by just putting in a flush statement to force your output.
Is this how you get, like, things like Vim to work? It's like buffered output every time you type something, or like the end invaders you just showed us.
Yeah, so those are different. Those have to put the terminal into what's called a raw mode. And normally it's in a cooked mode. And so you put it in raw mode because, when you say fgets, you start typing, your code is still sitting in the call to fgets. It doesn't come back from an fgets call until you hit enter. Which is why if you type 100 characters, backspace all of them, type 2 characters and hit enter, your buffer only has 2 characters in it. So that's a cooked mode of input. If you put it in raw mode, you can set it up so as soon as you hit 1 character, the call comes back right away and says, hey, I got a character. And that's another thing that's kind of a nightmare. Well, most things are nightmares in C, honestly. That's another thing that's kind of a nightmare in C, is trying to condition your terminal line to do different levels of input. And if you want to go down that sinkhole, look at the stty command. And this is a chapter 1, Linux command you can use, but there's also a chapter 2 or 3 version that you can use to condition an IO stream to respond differently. And I think this gets into some of the cooked raw stuff. So yeah, there's a dash cooked and a cooked. Dash cooked is the same as raw, and so on. And when you really want to go down a rabbit hole, look at IOCTL. Because that's what makes all of this stuff work. That's the system level call, which is used to actually manipulate the underlying I/O streams. And so when you do a read in bash, and you say read-C1, which says come back after a single character, or read with a timeout of 5 seconds, or things like that. Ultimately, all of that stuff is a bunch of IOCTLs. And it's great fun to program with, because if you mess up, you leave your terminal unusable, and you have to go to another window and kill this one and go back to where you were, and so on. So it's good times. System programming, it's a great course. It's one of my favorite courses when I was in school.
Yeah, I want to learn some more about streams and how they work.
Yeah. It's one of the pathways to like deeper knowledge on operating systems, is to look at all the I/O stuff, and especially in Unix, because of this thing we say over and over in 224, everything is a file. Well, it really is true. So if you understand all the mechanisms for doing input-output, you kind of, that's a pathway to all the other stuff like physical devices and networking and all that sort of stuff.
Yeah, I've kind of messed around with that stuff on a network level.
Mm-hmm.
And C#, which is higher level, but the way I was using it was more lower level, I guess.
Okay.
With TCP sockets, and I built up a class around it, so I
Cool.
didn't have to mess around with all the lower level stuff, but I didn't quite understand all the stuff that was going on with streams.
Okay, yeah. Yeah, and if you take a networking course, you can get into the nitty-gritties of TCP/IP and that whole stack, and that's also really good stuff to dig into. I don't remember if we played with sockets this fall in 224 or not. Sometimes I do that like the very last week of the course. I just talk about it a little and show some code. But we'll definitely get into sockets in this course. It'll be the main way we communicate from machine to machine. And PA5 will be a networked version of a game that you'll write in PA4. So we'll get into all of those details in due time.
I think I did that project on my own because we did in fall.
Okay, cool. Good deal. All right. So any questions or comments? Thoughts? All right, so let's talk about iterators. So if you have an array of things and you want to do something like, search your array for a particular type of thing, or do some operation on all the things, like an array of integers, maybe you want to add them all together, or you want to look for the largest integer in your array, or you want to count how many times a 0 occurs, but for some reason you want to go through every element in your collection of things, right? If you have an array of integers, that's a trivial operation to do. It's a for loop, right? If you know how many things are in the array, you just iterate from 0 to the index of the last thing, and array bracket index, that gives you, that element from your collection, and you can do whatever you want with it. So for arrays, right, iterating is usually just going through a for loop and pulling things off. For a linked list, you can, if you made the linked list yourself, right, you can start with the first node, you can do something with its data value, and then you can follow the next field to get to the second node and do something with its value, and so on and so forth. For something like a hash table, though, we have a problem. And we talked about this in 222 a little bit. If you have a hash table, what does this look like? We've got an associative array, and so we can view it as something like this. It's this set of key value pairs. And so here's Nick, and the value there is 25, and here's Steve, and the value is 33, and here's Jane, and the value is 29, and here's Zog, and the value is 111, and here's Betty, and the value is 18, and whatever. And if I wanted to find the largest value that's stored in my hash table, I don't have an easy way to do that, because I can't say, let's look at the first thing in the hash table, let's look at the second thing in the hash table, and so on. I need some way to go through each of the values, each of these key value pairs in my table one at a time, and do whatever I want to do with the values. And as a hash table is defined as an abstract data type, we don't have a way to do that. And even though it's implemented in an array, and I could think of it as, hash bracket Nick, hash bracket Steve, or whatever, if I don't know what the keys are, I can't use those to get to these values. And so whenever we have some kind of hash structure, we've got to have some way to iterate through the elements in that hash. And so in Java's implementation of a hash map, we have a variety of options. So we can create what's called a set, which is a different type of collection, and we can create a set of key value pairs. We can do something like a for each, which goes through the elements one by one. We can also do this thing called a key set, and this will give us a set of the keys contained in the map. So a key set would be something that would return to us a collection containing Nick, Steve, Jane, Zog, and Betty. And if you look at what a set is, it's paragraph after paragraph of description, but it has a method called iterator. And iterator is a method that returns, guess what, an iterator over the elements of this set. Well, what is an iterator? Well, this is going to be more long paragraphs of description. Oh, not too bad. But an iterator is a thing that has a pair of methods, has next and next. And this is a general mechanism for a lot of structures and a lot of classes in Java. And it's a common theme across, you know, most languages. So the idea would be we would take all of these keys, we'd change them into a set, and then from the set we'd get an iterator, and then from the iterator we could say has next and next. And each time that we call has next, it will tell us, is there a key in this set that we have not seen yet? And if there is, has next will return true, and when we call next, it will give us another key from this set. And after we've called next 5 times in this case, if we say has next, that'll come back false, and at that point we know we've seen all the keys. And then for each key that we get, we can, you know, use a get on the hash to get the corresponding value, and then do whatever we want with that value.
So I ended up using a for in my print method, or my toString method.
Mm-hmm.
And so I did for, and then I did the set, or get key set.
Mm-hmm.
Or, yeah, key set.
Yeah, key set.
And then the colon functionality, I guess, for the for loop.
Okay.
For each.
Cool.
Yeah, I wasn't sure if that was something you're going to touch on.
Probably not, but that's a good way to do it.
So, I understand the concept of iterating through. How do you access the value?
So once you have a key, right, you can just use the plain old get method for the hash map itself. So you can say hash map object.get, give it a key, it'll give you back a value. So we've got some time here. Let's get ourselves in trouble. And let's play with this iterator. I haven't done this in a year. I don't find myself using iterators very often. So this may blow up gloriously. But that's how you learn stuff. Alright, so here's our public static void main. Let's make a hash map. And let's make it a string and an integer. adding the number of letters in each person's name. That's the data associated with them for some reason. But this one will be a ringer. All right, so we're just adding some data to our map. And let's make sure this works. So this is IT main. Four errors for like a 4-line program. How about put? All right, so there's our hash map data, and as you can see, when we call the toString method, right, the order in which it returns these key value pairs is pretty much unrelated to the order in which we put them. It was Nick, Carol, blah blah, and big long name, and it came back big long name, Nick, Carol, and blah blah. So the order is not guaranteed, but this may correlate to the order that the iterator gives us our stuff back in. We'll see if that happens or not. So let's so let's get a set of keys. Set keys equals, and we're just going to use the key set method on our map. So this is going to be map.getKeys. And to declare keys, we're going to have to say this is a set of strings. So set string keys equal map.getKeys. And to declare a set, I'm going to have to use java.util.set, I believe. Get keys. Is it all lowercase? Key set. All right, so we're off and running. We've got a set of keys. Let's get an iterator for this set. So if we have a set, we can say iterator, which we return an iterator over the elements of this set. And iterator is generic. We have to tell it what kinds of things we expect to find in that set. So in this case, it's going to be still a set of strings. So iterator string it equals keys dot iterator. And set itself comes from java.utility, sorry, iterator. Comes from java.utility. So let's see how we're doing. Doing good. Iterator it, so it should be an iterator. And then the iterator method, iterator class comes with this pair of methods, has next and next. So we made a hash map, added some stuff to it, printed it out just for fun, got a set of keys from it, got an iterator from that set. Now let's iterate over each key value pair. So we'll say while it.has next, So the next key is equal to and I'm just going to call it key. So I'm going to make this a string. Key equals it.next. So this is the next key. I'll print out what the next key is, and then I'll print out the data value associated. The data value is equal to, and the data value will be map.get parentheses key.
So when you say you're printing the next, you're printing, like, say you're using this for the most common word, right? So would next be the one you're on, or is next the next key in the map? Like, how can you tell if you're printing incorrectly?
So if I've just created a set from this hash map, and my set contains these keys, right? The first time I say has next, it will be true. If I call next, it will give me the first key according to some ordering it has in mind. If I call next again, it will give me a second key. If I call next 5 times, the 5th time it will give me a 5th key. If I were to call next a 6th time, I would get an error, but after calling next 5 times, has next should return false. So the first time you call next, it's actually the first key you're getting back.
So in that case, if you're going through a while loop to check each set, you could set your string basically to the dot next.
Mm-hmm. Yeah,
And
so
set it for the one you're on, not the next one in the sequence.
yeah, so next is a little bit of a misnomer.
Okay.
You're starting with sort of, you know, no key at all, and when you say next, that gives you the first one.
Okay, that makes sense.
Okay, cool. So yeah, so in here at the top, if I have a next key, I'm just going to set key equal to next, and that should be the first one, and that should go through a total of 5 times, and then at the end, let's just print a message. Those are all the keys, and we'll leave it at that. So that compiles. That's good. We're done, right? We don't have to actually test it because it compiled. Okay, I'll test it. So, so the first key it gave us was big long name. The corresponding data value was 23. That looks good. The next key it gave us was Nick with a data value of 4, and then Carol with a value of 5, blah blah, with a value of 8, and then it said those are all the keys. So that seems to work. And the nice thing is this is a sort of very general mechanism that we find for lots of different classes. And it's a useful way to, you know, go through things one thing at a time when you don't necessarily have another way to access, you know, the first thing, the second thing, the third thing, like with an array, for example. And it's a parallel structure to what we do with our scanner, right? We say, you know, well, scanner.hasNext, get the next thing from the scanner, or hasNextLine, get the next line from the scanner, and so on. So it's a pattern that we'll see a lot. And we can write iterators without too much difficulty. So there was some conversation in Discord about string iterators, and so I posted some sample code in there for a string tokenizer.
Do most of these classes have like a separate iterator class like string?
A lot of them do. So string does not, but linked lists do, hash maps do, most of the collections and sets, array lists, things like that do. But the example I posted in Discord earlier was you could make a string tokenizer, right? A string iterator that lets you say, you know, construct a string iterator as a new string iterator on some string, and then, well, that thing has a next character, just use the nextChar method to get the next character. And this will feed your string to you one character at a time. and that's not a built-in. That's something that, you know, is sitting under this mythical CSE223.stuff package, and so you can import it. But it's pretty easy to write that. It's a few lines of code, right? So the constructor basically starts off a position at 0 and saves the string that you're trying to tokenize. Has next car tells you if you've already returned the last character of the string, and then next car just uses the car@, method in the string class to return that character and bumps up the position. And so this works like an iterator.
Is there any way in this language to implement your own iterators, like on your own class? Maybe like something you can override.
So I mean, you can do something like this, or maybe you could extend the iterator class and put it in something like that. But it's not a whole lot of mechanics that are required for an iterator. I mean, the iterator itself has 4 methods, and mostly we're just, you know, has next and next. And you can always define your own classes, right, and have them do whatever you want. Now you could try to extend the string class, but I think string is declared as final, and so I don't think you're allowed to actually make an extension of it.
So it's just some kind of base class and you also inherit object and iterator on it.
Yeah.
Or you have to inherit iterator. It's interesting because in some of the other languages I've seen, like Python and C#, it's always an interface or an abstract base class.
Mm-hmm. Yeah.
To the last, or the iterator code you just wrote for the list we made.
Mm-hmm. So, so that's the way I was using it. Oh, you mean for the hash map?
Yeah.
Yeah. Let's see. There we go.
Awesome. Thank you.
Yeah, you're welcome. And I'll push all this code over to the Linux server after class. And if people aren't aware of that, there's a link to it in Canvas, but it's basically just linuxengrcs.com. twiddlenix/shared, and there's a 223 directory, and there's all the sample code from different classes, and it's usually the same stuff I do Monday and Tuesday, and then the same stuff Wednesday, Thursday, but sometimes different versions of the code, so you can click through to those. All right, other questions, comments, thoughts? All right, well, let's see, where are we going? So you have until Monday morning to finish PA2. I've started to get some submissions already, which is great. But you have until Monday morning. And then Monday, Tuesday, we'll go over PA3. And PA3 is going to have you implementing a binary tree called a decision tree. And it's a data structure we're going to use to implement our version of a game called 20 Questions. So 20 Questions is a game 2 people play where one person thinks of something and the other person tries to guess what they're thinking of. And you're typically allowed to ask yes/no questions, and based on the person's answers, you try to figure out what they have in mind. And if you actually play it with 20 questions allowed, and you're very good at asking your questions, you can figure out almost exactly what somebody's thinking of. Because 20 questions actually lets you differentiate among a million different possibilities. So we're going to implement this in Java. and it's going to be a Java program that will try to guess what you're thinking of. And so you'll think of, you know, a purple bunny smoking a cigar, and it will ask you yes no questions, and hopefully at the end it'll say you're thinking of a purple bunny smoking a cigar. And the cool thing about it is the program will get smarter in some sense the more you use it. So the first time you run it, it probably wouldn't come up with that as a guess. But once you've played that game and told it that, if you ever think of a purple bunny smoking a cigar again, it's going to guess it, right? And so this is a pretty simple data structure to implement. It's basically a binary tree. And playing the game is a matter of traversing the tree in a very particular way based on answers that you're given from the user. So that'll be our third assignment, and we'll go through that in detail next week. But you already have the mechanics you need for Java to implement this entire program. And we'll go through the specifics of the algorithm, which will be this decision tree. But that's a fun program to play with. So we'll do that on Tuesday. And then I'm probably going to start next week getting you to download and install Eclipse and get that environment ready for programming assignment 4, which is going to involve doing some graphics. And so we're going to want to switch to an IDE. So we can use a package of classes called Swing for creating graphical objects and widgets and buttons and drawing panels and things like that. I'm in the process of trying to find a good combination of version of Java and version of Eclipse that'll work for most people. So I'm going to narrow that down over the next few days, and I'll probably put together a video and go through the download steps, and then we'll talk about that next week after PA3. That'll just get us ready for PA4 once we get there.
If it helps, I got a good version of Eclipse. It's the 2021-12.
Does it have a fancy name or a letter or something, like Neon or R or something like that?
No, it's Eclipse IDE for Java developers.
Okay.
And that's version 2021-12.
Okay, I'll take a look at that one.
That's what we use for Bellevue College recommended.
Okay, cool. What is my current one that I'm looking at? So I'm looking at 2022-3, so slightly newer, but that was the one that came down. But yeah, it's a moving target, and the one that was at the top of the page that I downloaded only worked with Java 8, and I had Java 17, and it was unhappy about that. So, but I'll try 2112 if this doesn't work.
Yeah, this one seems to work with pretty much everything I've tried.
What version of Java are you running?
I believe 8.
Okay. Cool. 8 is, you know, I feel like 8's been around the longest of the ones that are still in use, and it's very stable and very popular. But inevitably, I get people in class wanting to run 11 or higher, and that makes grading complex for me. So I'm finally upgrading for the class to at least 11 and maybe 18 or something. But we'll see.
What's the community support like on Eclipse? Are there other languages besides Java?
You can use Eclipse for other languages, although I've tried using it for C and it was very odd. It works really well for Java when it works, but there's been times where that hasn't always worked. There was a time when I forget what exactly it was. Something went from version 9 to version 10, and Window Builder, which we're going to be using, totally broke because the people who coded it took the first digit of the version number and compared that to the number 8, and if it was smaller it said, sorry, you need a newer version. So when this thing got to version 10, it looked at the first digit, which was 1, and it said, oh, version 1 is too old. And I looked around online, and the storyline from Window Builder was basically, yeah, if anybody wants to fix that, please let us know. we'd really appreciate it because it's community supported. So that's been fixed finally, but it's a little bit of a hit and miss proposition. So what I want to do is pin down, like I say, a particular version of Eclipse and Window Builder and Java up front, and let people know how to get those, and then we can kind of run with that through the quarter and hopefully not have things break halfway through. But yeah, Eclipse will work for other languages. It also works well for like I have a Garmin TriWatch that has an API, and you can write your own apps for it, and they have plugins for Eclipse that work really well with that. Android development used to be done under Eclipse, but it was a real dog performance-wise, so they switched to basically IntelliJ. But Eclipse has been around forever, and a lot of manufacturers have targeted that platform for their particular development system. But I mean, it's an IDE. It does things for you. It does some things you want. It does some things you wish it wouldn't do. You can usually convince it to do anything else that you want it to do. And it auto-completes and checks syntax, and it compiles every time you type a character, and so on and so forth. So it's mostly harmless. I prefer it for this class over things like IntelliJ because it's pretty good about getting out of your way when you want to just write code. And IntelliJ feels like it constantly wants to backseat drive. It actually wants to front seat drive. It wants you in the back saying, no, don't do that. So for people who are learning Java, I prefer that they're doing more of the driving themselves. So Eclipse seems to be a sweet spot. I've used NetBeans before, but NetBeans has kind of grown the way of some of these other IDEs, and now it's fairly in your face with what it does. But the main reason we're going with an IDE at all is because we want to start doing GUI development. And we're going to use Swing, which is a package of different classes that let us create, interactive elements we can click on and so on and so forth. And the amount of code you need to write just to get a basic hello world up is significant. And it's much easier to sort of have a tool that will write that stuff for us so that we can worry about, doing the creative part of our coding instead of the kind of boilerplate, 60 lines of code to create a basic window that we can open and close. So this won't be until PA4. We're still going to do PA3 on the command line. That'll work fine, but I want to get people to the point where everything is installed on your system and ready to go once we're ready to start PA4, which will be like another 2 weeks. Alright, so that's just kind of a look ahead at where we're going. We'll talk about PA3 on Tuesday. We'll talk about class extensions after that, and we'll start moving towards doing some more intense use of packages. Alright, got office hours tomorrow morning, 7:30 to 8:30, I believe. So I'll see you there if you come in. Otherwise, have a great weekend, and I will see you next week. Alright, bye.
Have a great weekend.
Thanks, you too.
Thanks.
Have a good day.
You too.